Hello, everyone. Um, Thank you for taking an interest in our SignX hackathon at ETH Global. I'm Jack. I'm the CTO of ETHSign. Today, we're going to basically do a walkthrough of the Sign protocol smart contracts, how to interact with them, what are some of the core concepts like schemas and attestations within the system, and what it might be used for. So basically, we're going to create a smart contract that interacts with the existing Sign protocol on the base Sepolia testnet. And the contract that we're going to write is something called actually met in real life. Okay. So before we get started, for you to get started, you can come to this website. So ETHSign, github.com/ETHSign/forge hard hat template. This is actually a Solidity template that I made. You do need to install Forge beforehand. Hard hat, you don't have to. You need a node environment, preferably node 20, which is the current LTS version. Okay. So you can install Forge at I think it's a Git Foundry or something. So just look up Foundry Forge. Yeah, book.getfoundry.sh. So you can install it by following these directions here. Okay. So, and once you've done that and you're able to use this template to create your own repository, which is what I've already done here. I made a repository called Sign Protocol EVM Demo 0. Okay, I just made it. I haven't done anything to it yet. Okay, so what we're going to do is we're actually going to open up VS Code and we're going to start writing our stuff. But before we actually start writing, so I should give you a little bit of an intro to what is Sign Protocol. Okay, so Sign Protocol is an omni-chain attestation protocol. Okay, and what we're able to do is we're able to enable people to post or attest structured data on chain, and that structure is predefined by the schema. So that what that enables us to do is, or not really us, everyone to do is, you're able to define a standard for the type of data that you're going to upload, and other people will be able to correctly decode your data based on the format presented in the schema. We also have a sign scan. Okay. Okay, that's terrible. I should know better. Okay, there we go. Scan that. We have to work on that SEO, obviously. So we have the Sign Protocol Attestation Explorer. So for example, let's say ETHSign, which is our other document signing product, right? If you look into the schema name, it's called an ETHSign signing event. So basically, every time someone makes a signature on ETHSign, we're going to make an attestation here that conforms to the data defined in this schema. Now you're seeing 23 days ago because we haven't set up the real-time attestation posting stuff yet. This is like we have to run the script currently periodically to onboard the data, but in the near future we're going to actually make it real time. Okay, so there are a few components to a schema, right? So you have the schema name. Okay, the ID is auto-generated. Okay, and we have a description. Okay, so and also the schema name, the name is only available for Arweave-based schemas. So Sign Protocol is present on quite a few chains. You can see it here. We're present on all of these chains. Base, Ethereum, X1, which is OKX, is L2. OPBNB, Polygon Scroll is Zeta Chain. Okay, but we're also present on Arweave. And the cool thing about Arweave is that, which we won't show today, but the cool thing about Arweave is that storing data up there is extremely cheap. Okay, and because of that, you're able to store more data on Arweave at a lower price. But the downside of that, excuse me, the downside of storing things on Arweave is that if your attestations are all posted on Arweave, then smart contracts actually, I'm sorry. In smart contracts, they're not actually able to interact. For example, read the contents of the attestation. So today, what we're going to be demoing is actually EVM-based attestations. Okay, so we have a description. Okay, created at, that's just a timestamp. Maximum valid time frame. So what this does is, in the schema, you're able to set basically the expiration, not the expiration, the duration of which the attestation made remains valid. Meaning that, for example, if you set the maximum valid time frame to like 1 hour, then that means the attestation that you make under this schema will expire after an hour of its from its creation date, creation timestamp. Created by, that's just an address. Okay, whoever called the smart contract. Data location. So as I mentioned before, you're able to store data on different platforms, and that data refers to schema details, or if you go into an attestation here, the decoded data or actually raw data. Okay, so if you want to store this JSON on the EVM chain, then it's actually going to be quite expensive. But on Arweave, it's very cheap. So this is what the data location does. Okay, transaction ID. This is an Arweave transaction ID. If you click into it, we can actually see the data that's being posted up here. Okay, so this is an Arweave block explorer. Revocable attestations. Now, what this does is it basically governs whether an attestation is able to be revoked by its creator. Meaning that, so for example, let's say we have a schema that represents some kind of club membership, right? And when you're joining the club, the club administrator, they will make an attestation attesting to the fact that you've joined the club, right? But the thing about club memberships is that, they can always kick you out, or if you don't pay the fees, or if you do something really heinous, they can kick you out. So in that case, revocable attestations will actually be true, or yes. And if you do something really, really outlandish, or you don't pay your fees, then the creator of the attestation can actually, which is the club administrator, they can actually revoke your membership. So revoke the attestation that represented your membership into the club. Okay. The schema details. This is a data field of the schema. Okay. So data field, by default, our sign scan, we expect either a JSON input, or depending on the data location, a CID that points to an Arweave piece of data, or something on IPFS, okay, or something on chain. If it's something on chain, it'll just be displayed here raw, without any redirections or fetching. But if it's an Arweave CID, which is the case here, then all of this will be fetched from Arweave and displayed here as a JSON. Okay. So that's the schema part. And if we look at the source code, this is a schema. Okay, you can see there are quite a few things in here, and this is all very. I like to think it's pretty well documented, right? So we've got address registrant, which is the person that did that registered the schema. Bool revocable. So if the schema is revocable, data location. This is a struct. Basically gives you a few options. There's on-chain, IPFS, Arweave, and custom. Okay. A max valid for, that is that's the maximum valid time frame that we talked about. Now this is something interesting. ISP hook. So this is only available for EVM contracts, for EVM signed protocol contracts, and also in the future, Starknet and Solana. So what the hook does is it enables, as someone is creating an attestation, it allows a predefined hook to be called. and this hook has to conform to our custom hook interface. It basically allows you to, it's just a call hook. It's a call hook. It's what it is. Okay. Timestamp, this is when the schema was created, and data, so that's the data part that we showed here, which is this part, schema details. Okay. So that's a walkthrough of the schema, and the technical walkthrough at least. And actually, you know what, let's just keep looking at this one. So this is an attestation, okay, so because we looked at the schema. We've got the timestamp, okay, and expiry. So this is governed by the maximum valid time frame. If it's set to 0 in the schema, then that means, so you can actually set, you're able to set the expiration of the attestation separate from the maximum valid time frame in the schema. So for example, if the maximum valid time frame in the schema is 1 hour, then it just means that your expiration date cannot be further than 1 hour from the creation date of the attestation. It could be like closer. It could be like under 1 hour for sure. It could be half an hour, right? And the attester is just whoever that made the attestation. And you can see this one points to a schema, a data location, okay, same thing, which is where all of these things are stored, and also referenced attestation. So we have this concept of linking, of being able to link attestations together. So one attestation can reference another attestation. So you can almost think of this as recording your state transitions explicitly instead of, so for example, if you want to revoke someone's club membership, the example that we used. So there are two ways. There are two ways of doing it. One, you can make the schema. In a schema, you can say that, okay, the attestations are revocable, so I can just revoke it later. Or a second option is that you can use linked attestations, and you can just as a club administrator, if you're trying to revoke someone's membership, you can basically make a new attestation saying that, okay, I'm revoking this person's membership, and you're referencing the previous attestation where you granted them the membership. So it's just a way to kind of string different attestations, different related attestations together. Okay, and revoke, there's a yes or no. Okay. And this one is also stored on. This one has the data that's stored on Arweave. Okay. Okay, so that's an overview of the structures. Actually, you know what, before that, let's just look at the code as well for the attestation. So we've got schema ID, linked attestation ID, attest timestamp, revoke timestamp, attester, valid until, revoked recipient's data. So you can also have a list of an array of recipients, and those will be indexed by our sign scan. So for example, like if I'm a club administrator, I'm trying to grant membership to like 2 people at once, so I can have 2 recipients here. Okay. So recipients, and obviously, you can do this inside of data, no problem. But recipients, this is explicitly indexed by our indexer, whereas data is just kind of shown. You can't search, you cannot look up based on the contents in the data, but you're able to look up recipients. You can filter by recipients. In our sign scan. Okay. There's also the concept of an off-chain attestation, meaning that you already have the data stored elsewhere, and you just want to kind of timestamp your data. Okay, so for this one, you only have the attester and the timestamp, and this actually lives inside of the mapping. And the key of the mapping, the key of the mapping will basically be whatever your data ID is. So an off-chain attestation record, meaning that, all you want to do is, again, timestamp on our platform, and you're not interested in onboarding the data over here, which we also support. Okay, so let's actually get started building this met in real life kind of smart contract that makes use of Sign protocol. Now, why do I call it actually met in real life? Because if you think about it, a lot of attestations nowadays are really half attestations, right? So for example, if I So for example, so there's this, so let's just talk about the Met in real life schema, which a lot of people, they like to use as an example. But so the problem is, right? I can attest right now that I met Joe Biden in real life, or I met Vitalik, or I met Trump in real life, right? However, it's just what I claimed, right? There's no way for you to verify if I actually met them in real life, right? I can just claim from my side whatever, and it doesn't even have to be true, right? So this is why I call like a lot of the attestations nowadays half attestations, because it's just one party claiming to have done something, but have they really done it? You have no idea, right? Because it's just that one party making the claim, right? Now, of course, you can say that, okay, in order to make it valid, I need the other party to also attest. But once you do that, it kind of becomes, well, it doesn't become annoying, but there could be a new schema used for that, right? And for us, what we're going to do is we're actually just going to do that. We're going to create a new schema called actually met in real life. And our smart contract will actually act as a gate, so that basically this actually met in real life attestation will only be met if both parties they come to a smart contract and say that, okay, I met the other person in real life. Okay, and the second attestation, the second contract interaction that basically affirms that they actually met in real life, that will trigger the actual attestation being posted. Okay, so here we go. So I already cloned the repository that I made earlier. Okay, I call it Sign Protocol EVM Demo 0. And this is just, you see this counter.sol, counter.t.sol. These are all just from Foundry, and they're here by default. Okay. I also ran, well, you can't see it here. I also ran pmpmi, which installs all the packages. By default, I have quite a few packages. Okay, so what we want to do here is we also want to integrate the package from Sign Protocol, right? So to do that, I did package everything into an npm package here, which, okay, it's not loading, but it's okay because I have the, oh, there we go, yeah. So this one here, okay, so that's the name. So what we're going to do is we're going to copy it over here, okay, and let's just say, oh, it should be before that. Okay. So now that we have this, let's install this again. Okay. So now that we've installed this package, what it does is basically it gives us access to the contracts of Sign Protocol, okay? So that you're actually able to interact with the existing on-chain smart contracts, okay? So the first thing that we're going to do is let's just delete the test because well, we're just doing a demo, so we don't really need to test our code. Although obviously, it's a good practice in general programming. So after deleting that, let's just rename this file to actually Met IRL, because, well, we're not going to use the default counter. So after that, let's just delete the template, the default code that it had, and bump the Solidity version. Change license from unlicensed MIT, because this code will be available later for everyone to reference. So let's actually, let's start our game plan here. What are we going to accomplish in this contract? So the first thing that we're going to do is we need to have a way to link this smart contract to the existing on-chain Sign Protocol instance, because we're going to be interacting with an existing Sign Protocol deployment. The second thing is that obviously, which is the core of this idea, which is to force both parties to confirm that they've met each other in real life before making an attestation. And the third thing, which we actually didn't end up doing, is that originally I planned to have a way to register a new schema using code to demonstrate that, but kind of ran out of time in the recording afterwards. Also, the audio is different because halfway through recording, I actually lost audio and I didn't find out until I finished everything. So this is like a voiceover that I'm doing afterwards. So going to inherit from ownable because we do want to impose some access control on some of the functions. So for example, only the owner should be able to set the sign protocol instance that this smart contract points to. In order to do that, obviously we have to import our sign protocol interface. So I was forgetting the path there. And just to note, right here I actually forgot to fix the remapping, which I did later. But in a hybrid hard hat and foundry project, every time you install a new package, you kind of have to fix a remapping because Foundry by default uses Git submodules, but I'm forcing it to use npm packages. So we'll have to remap the paths so that it's able to find the package. So we created a variable called sign protocol instance that holds basically a reference to the deploy sign protocol contract. And also, because in order to make an attestation, we need to attest it under some schema. So we're also setting the owner should be able to set the schema ID, the schema that we're going to use, right? So that function also needs to be only owner, and the schema ID is a uint64. Okay, so now we have to figure out a way to kind of keep track of the records, right? Because party A is able to claim that party B met them in real life, and party B should be able to come later and then confirm that claim, right? So we need a data structure that supports that, and we decided to use a mapping that maps from an address to another address called Met IRL mapping. And exactly how we're going to use that, we'll demonstrate it in a second here. So we're going to create a new function called claim Met IRL. So this is the initial claim that by party A that, okay, party A is basically saying that, okay, I met party B in real life. I'm making this claim. And this claim, when this function is called, this claim is actually unverified. So party B will have to come over and verify this claim here. So what we're doing here is we're writing the second function, confirm Met IRL. So this is the function that's called by party B to confirm a claim made by party A, right? So we're saying that, okay, if we're basically looking up party A's claim and saying that if party A is claiming that it met us and we are actually confirming it, if the addresses are the same, then we're going to proceed with the confirmation. Otherwise, if party A is claiming that they've met someone else and we're making that claim, we're trying to confirm that. Obviously, you can't confirm that party A met with someone else because the whole point is to have the first and second parties to confirm the facts themselves. And here you can see that I was fixing the remappings that I kind of forgot to do earlier, in order for Foundry to be able to find the files. Yeah, turns out I actually had to reload the workspace for it to work. Yep, here we go. Okay. So once we have confirmed that our address matches with the claim that we're trying to confirm, we will actually go ahead and create an attestation on sign protocol. So yeah, so you see we're deleting we're skipping over the register function demo because we kind of ran out of time. But the function that we're going to look at is this attest function, right? So the main thing is to pass in the attestation struct. The indexing key is purely optional. Delegate signature is something interesting. It's kind of like an ERC20 permit where you're actually able to make an attestation on someone else's behalf. You can also create a schema like that as long as the original party has digitally signed it, right? And extra data is just something that's passed along directly to the hooks. It's totally optional. Usually you can leave it blank unless the schema maker, the creator of the schema, specified, and they're looking for some specific type of data. So now, because I have to create that struct, we're importing an additional attestation struct. So we're going to create that struct right now. And the data inside of the struct is actually, we also want to talk about this. So obviously schema ID, because each attestation needs to be made under a schema. Linked attestation ID, so each attestation, so let me adjust the input gain here. So each attestation is actually, you're actually able to link it to your previously made attestation. And attest timestamp and revoke timestamp. So these you can just pass in 0 because the Sign protocol contract will override it anyways. It'll make sure that the timestamps are correct. Attester, so this you have to input the address of the attester. In this case, it'll actually be this Met IRL contract because this contract will be the caller. Now, if the attester address is incorrect, then Sign protocol, the smart contract will actually throw an error. Valid until, so that's the maximum valid time frame that we talked about. 0 just means it's valid forever. Data location, it is an enum, and it turns out I actually had to import that separately to kind of make it work, although really underneath is a uint. So 0 just means we're going to have that information on chain as opposed to on IPFS or Arweave. And for revoked, we're going to pass in false because obviously we're just making this attestation right now. And I believe if you pass in true, it'll also revert. So for recipients, recipients is a bytes array. The reason why I made it bytes instead of address because I was trying to, I was thinking about, future extensibility. Maybe you want to make an attestation on EVM that involves maybe like Solana or some other address format, then you'll actually be able to pass it in or encode the information in the bytes. But right here, we're just working with EVM. We're working with EVM addresses. So what I did was I just ABI encoded the recipient's address into bytes and pass it in. And data, we can just leave it blank because we're not really passing anything extra there. So now we're going to call the attest function of the Sign protocol smart contract. Now I made a mistake, so yeah, there we go. So you shouldn't call the type, you should call the actual object. So I'm only passing in the struct, and for the indexing key, we're not really doing anything with the front end, just a demo. Delegate signature, we're not really delegating anything, so it's empty bytes, and also extra data, that's empty bytes. And this attest function will return a uint64 that'll basically give you the attestation ID, and we'll just emit an event and then return that ID. All right, so let's actually take a look at some of the other overloaded attest functions here, right? So we also have another one that takes in resolver fees ETH. So if the schema specifies a hook and that hook expects payment when making attestations, we actually have the ability to forward payments made using the native token, or as you can see, we can also support any ERC20 tokens. And the receiver hook, the schema hook will actually have different functions that are called based on the type of fees that they expect. And the same thing goes for revokes, right? So if we take a look at the hook contracts, you can see that we've got did receive attestation, 2 of them. The first one's payable because we're expecting either no payment or payment in native tokens, and the second one has got more ERC20 payment parameters here, right? And we have that for both attesting and revoking. Okay. All right, so we're basically done, I think, with the smart contract so far. So now let's work on actually deploying this thing, right? So by default, the template that I made will give you an OpenZeppelin deployment script, but in this case, we're not really deploying anything upgradable. So we're just going to modify it so that it will just deploy something directly. And on line 5, actually, inside of deploy, it should just be empty. It shouldn't be an array. But and also we have to replace the actual contract name in on line 4. And we have to manually print out the address because we're not using hard-hat deploy. Now, the template does have hard-hat deploy in the package, but for the purposes of this demo, I just did it the simple way without writing a hard-hat deploy script. So after deploying the smart contract, we want to verify it so that we can interact with it on the Block Explorer. And so now we're on the Block Explorer. I was using a new computer, and also it turns out the default RPC on Polygon Scan is totally broken. So I had to actually go and add Mumbai using a different RPC. Yep. So chainless.org, always a very handy website for you to add your RPCs and new chains. So I picked one from Anchor. So these nodes from Anchor are usually pretty reliable. So we're just going to connect the wallets again. And yeah, so this is the contract that we just deployed. So now let's set the Sign protocol instance. Okay. So now we've done that. Let's then actually, because we didn't use code to create a new schema, we actually have to create a new schema for this actually Met IRL contract that we did. So registrant is just ourselves, and then revocable false, data location 0, that means on chain, max valid 4, the 0 means it's going to be it can be valid forever. Now hook, I've had to I wish they're able to just convert 0 into a 0 address for me, but I had to do that. Timestamp, you don't have to do it because Sign protocol contract will fill that automatically. So now we're just waiting for the transaction to be confirmed, for our schema to be live. So our schema is now live. You can actually see in the logs emitted that we have a new schema with schema ID 7. So let's now set that schema in our actually Met IRL contract, so that any new attestations will be using schema 7. So let me switch to my first account and claim to have met IRL with the second account, or rather my second account claiming to have met with the first account, whichever way around. Yeah, so my first account actually doesn't have any test.matic, so just transferring some stuff over. Right, so yeah, I had to reconnect. Yeah, so I'm using my my first account to claim, or my dev account to claim to have met with my personal account, and using my personal account to confirm that I've met with the dev account. And you can see that an attestation has been made through the event logs, and we can actually now look up the attestation that we just made with ID 6. So if you type in 6, then we can get the information that we just that we wrote from the actually Met IRL contract. And yeah, that wraps up basically the demo of this kind of little prototype application that we did. Now I have made this thing public so that you can look at it, look at the source code, and reference parts of it. Also, please come to our live workshop session, because in our live workshop session, we'll be talking about some of the other interesting use cases that we made. So this first one is an attestation gated Discord bot. Basically, it's kind of like collab.land, but you need to have made attestations in order to gain access, and you can customize the rules and everything. And we'll also go over the KYC gated access thing that we did for Zeta Chain. And yeah, that's about it for this pre-recorded demonstration workshop. I do apologize again for the audio mishaps, the switching over halfway through the video. And I will see you on April 3rd. I believe that's when our live workshop is happening. See you then. Thank you.